Dear participants, I welcome you to the lecture 15. In this lecture, we will be discussing about irrigation efficiency. In previous lecture, we discussed about measurement of irrigation water. We emphasized why measurement of irrigation water is important and how measurement can be made by using different devices. Irrigation efficiency can be monitored when properly measurement is done. We are interested that the amount of water which is given, how it has caused in improving the water use efficiency of the crop. So, here we will be discussing the concept used in this particular lecture is performance of irrigation system. We will be talking about irrigation efficiency. We will be talking about adequacy and effectiveness of irrigation. It is not only irrigation efficiency, but the overall considering the various other parameter which will be beneficial for overall benefit, including the market value, that is also equally important when we are considering the irrigation system design considering irrigation efficiency. Now, what is irrigation efficiency? So, irrigation efficiency is the ratio between the amount of water used to meet consumptive use requirement of crop plus that necessary to maintain favorable salt balance in the crop root zone to the total volume of water diverted, stored or supplied through a pumping system. So, it expresses the performance of complete irrigation system or component of any irrigation system. So, here what we are seeing that when the water is being supplied, it in this case the water is being supplied, it is in a closed system and this water is used for both bringing down the temperature and also water is being supplied to meet the crop water demand to meet the evapotranspiration requirement. What are the different causes which are affecting the irrigation efficiency? So, causes for reducing irrigation efficiency, it could be losses in the storage system, losses while conveying water from source to the field, that is a conveyance system, and then field application losses, means when we apply in the field due to irregular field condition, this may also cause a loss. So, irregularity in the field or there are the as such unavoidable situation it exists that field is undulating, field is having newly plowed soil, means this is cultivated, there are clods, that also makes a difference. So, evenness of the field, evenness of the system, that also, so during application and in the field condition, that also make the difference. So, irrigation efficiency of major irrigation projects it hardly it is above 40%. So, it most in majority of the places it is 35% or 40%. So, huge amount of water it goes as loss. Now, in order to meet the growing demand of water for food, environment, urban and industry, it is necessary to improve irrigation efficiency at all points. Means at all points, I mean to say from conveyance system, from the storage system, and as well as when we apply, then there should at the time of application also we should see that there is a minimum loss it takes place. When we talk of, there are different terminologies which are associated here. Overall system efficiency, it includes reservoir storage efficiency, conveyance efficiency, application efficiency, then storage efficiency, water distribution efficiency, water use efficiency. These are the terms which are associated in irrigation efficiency. Let us try to learn more deeper about irrigation these terms. So, when we say about overall system efficiency, when we are interested to estimate, so it is given by EI equal to irrigation requirement plus leaching requirement divided by amount of water supplied to the farm, to the field means. So, this can be further elaborated, that irrigation overall irrigation efficiency, it can be given by S minus dP. S is the amount of water which has been supplied minus amount of water it has depercolated minus runoff minus operational losses due to plant or accidental spillage from pipeline or overtopping the channels. So, those could be also means which the losses takes place either from the pipeline or sometime from the banks of the channels or canal water miners or distributaries water flows above the channel. So, those are to be accounted while we are finding out the overall system efficiency. Now, overall system efficiency, it is the product of reservoir storage efficiency, the conveyance efficiency and application efficiency. So, we need to evaluate each component. So, reservoir efficiency is one component, conveyance efficiency is another component, means means your system overall system it consists of several components. So, these three components it causing the effect on overall efficiency, irrigation efficiency. Now, what is reservoir storage efficiency? Reservoir storage efficiency is given by the volume of water which is lost plus volume of water lost due to evaporation and volume of water lost due to seepage divided by volume of inflow into the reservoir. So, this component is causing the loss. So, this is making the overall difference in the water stored in the reservoir, or this can also be given by the 100 into V naught plus delta S. Now, V naught is the volume of outflow which has the water has been used for some purpose plus change in the storage system. So, whatever amount of water it has been taken out from the reservoir divided by the total volume of water flowing into the reservoir. Conveyance efficiency, as the name says that it is a conveyance system. So, conveyance means when the water is being supplied through canal, miners, distributaries, open channel, and before it reaches to the field. So, from the source water it is supplied. So, when we are evaluating, we are telling that conveyance efficiency is given by volume of water delivered to the farm by a particular irrigation system divided by volume of water diverted from the source to the irrigation system. So, if we are evaluating these two terms, these are in the same unit. So, it comes in percentage when we multiply with 100. Application efficiency, it is the ratio expressed in percentage of the volume of water beneficially used by the crop to the volume of water delivered to the cropped area. So, it can be computed for each field of the farm or for the entire farm. Means there could be situation that farms are of different conditions in the field. So, means each sub unit of the farm would be up. So, at which particular place application efficiency is less, that can be improved instead of considering the entire farm. So, it can be if the farm is of a smaller size, that can be computed. If it is a large size, it can be made sub units, and then the application efficiency can be evaluated. So, volume it is means here it is given by V s by V f. So, volume of water is stored in the root zone to the volume of water delivered to the field. And so, volume of water which is stored in the root zone is this is the water which plant will be using for meeting the evapotranspiration requirement of the crop. Rest of the water, whether it is flowing as surface runoff or it goes beyond the root zone depth, that is not useful. So, this is stored water in the root zone is important from application of efficiency point of view. A typical application efficiency which has been reported in the literature from different irrigation system. So, here you can see for surface irrigation, it involves, we will discuss in coming class about the different types of methods of irrigation. So, if we see the surface irrigation system, the range of application efficiency, though it is given very high range, but such range does not exist in surface irrigation system. In practical sense, this could be at very highly efficiently at laboratory condition. In field, hardly we get 60 to 65%. In sprinkler irrigation system, this application efficiency, it could be in the order of 65 to 85. This is okay, and then micro irrigation system, the application efficiency in the order of 70 to 95%. Now, application efficiency applicable to micro irrigation system. So, here we will be discussing about Christensen coefficient, we will be discussing about the distribution efficiency, we will be discussing about the pattern efficiency, and emission means normally these the Christensen coefficient of uniformity, that is a CU, distribution efficiency and pattern efficiency, this is more relevant to sprinkler irrigation system. As far as the emission uniformity is concerned, this is relevant to micro irrigation or drip irrigation system. So, irrigation application distributions are usually based on the depth of water. Normally, in other place we are putting the volumetric form. So, in case of micro irrigation system, we use volumetric form because the discharge coming out of the dripper in a liter per hour. So, the amount of water which is collected in a given time in a cylinder, so it is expressed in the volumetric unit, but this can be converted in a depth form also. So, normally we use in volumetric form, and then we try to evaluate the statistical parameters, and then the means the values of water distributed in the field, it will depend upon the topography, it will depend upon the infiltration capacity of the soil, it will depend upon the hydraulic characteristics of the particular irrigation system, how it is working. So, this is to be evaluated. So, Christensen uniformity coefficient, it is mainly intended for the sprinkler irrigation system, where the depth of water is collected from the number of catch cans, means rain gauging, similar to the rain gauging kind of a system, where the depth of water is collected, and from the number of sample points we are taking, let us say that we are considering from 25 samples. So, from all the 25 values, depth of water which is collected, that will be evaluated, that what is the CU value. So, CU will be calculated, that is the depth or volume of water of each equally spaced catch container we will get, and then from all these 25 number of samples, means number of samples which we are taking, we will get the mean value. So, number of these values are summed divided by number of samples. So, we will find out the deviation from individual values from the mean. Next parameter for evaluating the efficiency is a pattern efficiency, which is given by minimum depth divided by average. So, minimum depth, say I was giving an example, there are 25 number of observations. So, we will from the 25 we will take the lowest value out of 25 number of observations, and then average is simply means the capital X, the small x, that is x I minus summation of individual values of 1 to n. So, average value will be used and multiplied by 100, this will give the pattern efficiency. These two efficiency term which I discussed, that is used for sprinkler irrigation system. When we are coming to the surface irrigation system, even this can be used for sprinkler irrigation system also. So, low quarter distribution efficiency. So, it is defined as the ratio of infiltration in the lower quarter to the average infiltration over the entire field. So, if we are say it is given by du equal to 100 into Vp by Vt. So, here du equal to distribution uniformity in percentage for the lower quarter, Vp is the mean application volume in cubic meter divided or depth in the lower quarter, or Vf is the your depth or of the means application volume or depth for the whole field. Now, here lower quarter means if the whole field is divided into 4 quarters. Now, the lower quarter means we will be as if the water is supplying from the upper reach to the lower reach. So, in the lowest part, what is the infiltration depth and then mean depth of this. So, when we are considering the average infiltration and then total means average infiltration and then the average infiltration from the lower quarter and average infiltration from the whole field. So, this is to be used. So, this is for the mean value for the lower quarter, and this is the mean application value at the for the whole field. Then distribution efficiency it is obtained. This can be used for surface irrigation and also for the sprinkler irrigation system also. The water distribution efficiency, it is the ratio between mean of numerical deviation from the average depth of water stored during irrigation and average depth of water stored the irrigation D. So, ED that is the water distribution efficiency is given by 1 minus y bar by d bar into 100. Now, y bar is your average deviation of depth of water stored in the from average depth stored during irrigation, and d bar is the average depth of water stored during irrigation. So, here we will be getting the values of the number of places where the depth of water which is stored, means it has, this is same as what I was telling, that infiltration depth it has taken place for the whole field during irrigation place, and then we will be taking the deviation from the mean here. So, here deviation from the each individual mean. So, that particular value, this deviation from the mean, it will be obtained. So, 1 minus y bar by d bar is used to find out the distribution efficiency, water distribution efficiency. It is a measure of water distribution within the field. So, low distribution means non-uniformity in the distribution of irrigation water. This may be due to uneven land labeling. So, this would be the reason that land is not properly labeled, or it is a newly plowed field where lot of clods are there. This could be also. So, smoothness of the field will also, it is more relevant to surface irrigation system. The other two important term which is used from the crop production point of view. So, we are using two terms, which one is crop water use efficiency and field water use efficiency. Crop water use efficiency is given by the it is crop yield to the amount of water depleted by the crop in the process of evapotranspiration. So, we say water use efficiency, crop water use efficiency means the to produce say 1 kg of grain yield, what was the amount of water which has been used by the crop to meet this. So, it is the it is expressed in sometime it is expressed in kilogram or in tons per millimeter of water used for evapotranspiration requirement. Similarly, field water use efficiency, it is the yield to the total amount of water used in the field. So, it involves evapotranspiration plus all other components of the water requirement, that is the field application loss, water special need for water which has been given for leaching. So, all the components which are associated to value of WR is more than evapotranspiration, and that is a useful information that yes, total water how much it is been applied, and that has made the yield to how much it has brought to the yield. So, that is a field water use efficiency. Depercolation ratio and tail water ratio, these are the two components. So, DPR is given by VDP by VF, and VDP is the amount of water lost due to depercolation and amount of water delivered to the field. So, if we are able, means after the infiltration process, the amount of water which is percolating below the root zone depth, that amount if we are able to measure, and then amount of water which has been supplied, then we can know that what is the depercolation ratio or depercolation efficiency. Tail water ratio, the amount of water runoff to the amount of water applied. So, runoff amount of water, if we are able to measure that water which is going out of the field from the border irrigation or from the check basin irrigation, when the amount of water it is going from the tail end, that how much amount of water it has gone out as a surface runoff, that amount of water is used to calculate the tail water ratio. The another the important term, it comes for adequacy of irrigation. Now, adequacy of irrigation is computed. It is not only the irrigation efficiency, there are other terms which are associated, the how the uniform water has been applied, and then how much water it has it is going as surface runoff, it is going as, but it not only water used, but what is the economic value or return which we are getting. So, the adequacy of irrigation is the percentage of field receiving sufficient quantity of water to maintain the quality and quality of production at profitable level. Here market value is important. So, it is determined by determining the cumulative distribution pattern, of the water which is infiltrated, or it is a caught amount of water caught or water which has gone infiltrated. So, infiltration volume, say we are, as I was telling you about the distribution efficiency or infiltration. So, depth of water which is infiltrated at different points in the field. So, suppose total area is it is we are considering that 1 hectare area. So, in 1 hectare area, 1/10 of area, how much infiltration it has gone, then what is the depth of infiltration at the second area, third area, and total 1 hectare. So, 0.1, 0.2, 0.3 like this total area, that will give the cumulative percentage area, but what is the depth of water it has infiltrated. So, let us say that first 2 centimeter of water it has gone to the first 10 means 0.1 hectare, then another 0.3 centimeter of water, 3 centimeter of 0.2 hectare. So, like cumulative values are obtained. This cumulative frequency distribution is versus infiltration depth when we are plotting. So, this particular curve which you see here, this curve is the cumulative distribution curve. Now, when we are putting here say a particular desired depth of irrigation is some certain amount. So, this desired depth of irrigation is certain amount, and if you are plotting this desired certain which is intersecting with the cumulative distribution curve, and let us say that it is a 50%. So, 50% is adequacy of irrigation. So, it shows that the percentage of field receiving given amount of water are more. So, 50% of field it is receiving desired depth of irrigation, 50% of field it is getting lesser amount of water. So, this is the adequacy of irrigation. So, when desired depth of irrigation fills the soil to field capacity is called storage efficiency. It is often used as index to adequacy. With respect to adequacy of irrigation, the another term is effectiveness of irrigation. So, effectiveness of irrigation, it is a qualitative, it describes the application efficiency, it describes the uniformity of water application, and also it includes adequacy of irrigation. These three terms are important from for effectiveness of irrigation. So, desired combination of efficiency, uniformity, adequacy maximizes net profit. This is means all three components are important for from the net farm profit. So, if we come to the what is the relationship between application efficiency and uniformity, considering the adequacy is constant. Now, here what we see here there are two systems which have been considered. One is system A and another one is system, means there are two irrigation systems and A. So, here in case of A we see the curve is flatter as compared to the curve B. So, flatter slope and smaller range of infiltration depth for curve A indicate system A applies more water uniformly than the curve B, because this is there is a steeper curve. Now, here what we see, the this cumulative distribution curve for A, the area under this particular curve you are seeing here A1, and here we see A2. And if we are considering the adequacy of irrigation at this point, this is the required desired depth of irrigation. Desired depth of irrigation means amount of water which has been applied to fill the up to the field capacity. So, this water which is the hatched line in case of row A1, it shows that it is the excess water or it is causing runoff, whereas when we go beyond this point A2, it gives the information about that it is under irrigation. So, this is excess irrigation, this is the deficit irrigation. So, improved uniformity. So, here the point is that if we are getting uniformity, it does not mean that the application efficiency has improved. So, benefit of high application efficiency must be carefully balanced with the cost which are associated with high uniformity of application, means application uniformity of water application as well as the adequacy of irrigation, and then the means this is or means there should be proper trade off between these components. If proper trade off means this is not considered, then we will not be getting the good price value or net profit will not be there. Then another component is of the effectiveness of irrigation is relationship between adequacy and application efficiency. When we are considering the means efficient means your the other component which I was telling you when we were considering the uniformity. So, now here we are considering that uniformity is kept constant and other part both the things are when we are varying. So, adequacy was decreased. Here we are seeing there are two curves again. This is the curve 1 for the system 1, this is the means cumulative frequency distribution curve for system A, cumulative frequency distribution for curve for the system B. Now, the adequacy is decreased from 52% to the value of 16%, and then the depth of desired depth of irrigation is means it is reduced, means adequacy is reduced from 52% to 16% between curve A and B by reducing the depth of application of water from 3 centimeter to rather it should be 3.5. So, 3.5 centimeter to 3 centimeter at a constant uniformity. The reduction in adequacy improved the application efficiency, and this will be true as long as means reduction in these two values it is bringing the the better application efficiency, because there is a lesser amount of water which is going as a loss. But this will be true when the surface runoff as well as depercolation losses take place, and but this needs to be balanced for higher profit, for higher means this is the again I am telling that here there should be proper trade off between balancing between these three components. It is not the only efficiency, it is not only the uniformity, it is not only the adequacy, all three components are to be considered while we are interested to get better market price of the produce. So, these are the means here what we these are the references which you can refer in the books where these terms are explained more in detail. And so, in this particular lecture we discussed about the different terms which are associated with the irrigation efficiencies and effectiveness of irrigation, adequacy of irrigation, and then all these terms are equally important while we are designing the irrigation system. And so, means to be discussed about all these things in detail, and in the forthcoming lecture we will work out numerical problem dealing with irrigation scheduling, water measurement and irrigation efficiency, which I discussed in today's class. So, thank you very much and good day.